This is Mr. Anderson for Kellogg Community College. We're going to be looking at Chapter 2, Section 5, Trigonometry, and in this first video I want to introduce you to all of the different types of trigonometric functions in graphing form. We're going to start off with ones that we've seen in the previous videos here. We took a look at sine and cosine. So what I first want to show to you here is I want to show you the sine of x as a function. Now the sine of x as a function, we're first of all going to, instead of using these numbers, I'm going to change these to 2's. I'm going to make these, let's see, -1 and 1, -2. Alright, now what's important about this is that the sine wave, if we consider this to be one cycle of sine, so we're going to mark this off every pi units, and we're also going to bisect these to make these every half pi units, going all the way to 4 pi, showing 2 cycles of sine. Starting off at the origin, we're going to go to 1 at pi over 2, then pi, then -1 at 3 pi over 2, and then back to 0 at 2 pi. So this is the one cycle of sine here, and here's going to be the second cycle of sine. Okay. And there we go. So there is our sine wave, 2 cycles of sine right there. Now, what I'm going to show you here is I'm going to show you the cosecant graph and how it compares to sine. Now, the definition of cosecant is 1 over sine. So what we'll do here is we'll actually use our marks from the previous picture here to kind of show you how this is going to play out. Now I'm going to choose a different color here and show you that sine is, or cosecant is really 1 over sine. Now what's kind of neat about that is that I can take this spot right here that's at the top of that graph and make a U with an asymptote line at pi, and this dark blue line is going to be my cosecant. There it is. Alright, and there's my asymptote line. There are no, this graph will not touch this cosecant, or this asymptote line right here. It'll get infinitely close to it, but never cross it. And you can see that at this moment, we will also have another inverse like this right there, and, or I should say reciprocal function right there, and here is another asymptote line at 2 pi. So we're going to make another asymptote line there, and at the negative, at this spot right there at pi over 2, and this spot right here at 3 pi over 2, we're going to have another spot where this turns around. Now if I was going to make these coordinates, this would be pi over 2, this location here would be pi over 2, comma 1, and this right here would be 3 pi over 2, comma 1. You can check your unit circle for those measurements. And I would just continue based on the pattern that we've seen so far, where this would be connected there at that moment, and this would be 4 pi over 2, and then this would be 5 pi over 2 here, comma 1. Oh, this would be -1. Forgot my negative there. Alright, so here's my curve. And we'll do one more just to show you 2 complete cycles of cosecant. And you'll notice that it is not continuous at those spots there, at these asymptote lines, but here you see 2 full completions of this. This would be 5 pi over 2, 6 pi over 2, or 3 pi, and this would be 7 pi over 2, comma, -1. So there is sine and cosecant. Now the other graph that we've spent some time with is cosine. So let's go and take a look at the cosine function. Alright, and cosine, again we're going to change our graph a little bit here, call this 2, 1, -1, -2. And cosine started at the point 0, 1, because at 0 radians or degrees, that's the x location is going to be 1. So as you go through a complete cycle to 2 pi, let's mark this by half pi's right there. So high, medium, low, medium, high, and there is our beautiful curve like this. Alright, so there's that. At pi, it has a low spot, and then here we're going to take another cycle, high, medium, low, medium. Sorry about the little dot there, my pen slipped. And then high, and then we're going to take a nice little curve that way. Okay, so that's going to 4 pi. Now let me change colors here and show you what this is going to look like. The asymptote lines are in a little bit of a different place. The asymptote lines for the cosine, for going from this y equals cosine of x to y equals its reciprocal function right there, which is going to be your secant of x. The asymptote line is going to be at the zeros. And if you're kind of curious about why these are, because as they get closer to 0, you get a division of 0 error, the closer you get to these lines here. So every pi over 2 becomes one of the turning places for this function. So we'll put our asymptote lines here at pi over 2. So these are between all the marks there. Alright, and one more to go. Alright, so this is going to start at 1. And the reason, a nice way that some people remember these is that cosine starts at 1 and so does secant. It starts at 1 and goes off from here. So this is the point 0, 1. And then it's going to turn around here at that spot at pi. So this location right there at -1, this is going to be -2. This is going to be pi, comma, -1. Then we're going to have another turnaround right there, and that is going to be at 2 pi, since this is 3 pi over 2 asymptote line, comma 1. And then this asymptote line is at x equals, let's see, the 2 pi, this would be 5 pi over 2, so that this turnaround spot right there will be at 3 pi. So let's attach that here. So this is 3 pi, comma, -1. Alright, we'll turn around here. And I didn't put my little spot right there as it's mapped over here, but we will have another spot to come down to match it right there. So there's that little spot right there at 4 pi, comma, 1. So there's cosine and secant. Now let's go take a look at our last two, which is our tangent and cotangent function. Alright, so tangent and cotangent. Let's go get maybe a new color here. Alright, so now the tangent and cotangent, I'm just going to straight up draw these, and one of the ways that I want you to do this is start with your asymptote lines at pi over 2. Pi over 2 is when these become undefined, and you'll notice that every pi over 2 for tangent, the tangent of x, is going to be undefined. So I'm going to make sure that I have asymptote lines at every cycle of pi over 2. So every cycle of pi over 2 is an asymptote line, which also means negative pi over 2 at x equals negative pi over 2. That's an asymptote line as well. And most of the time people start drawing tangent lines because from the origin. At 0, the tangent is 0, and if you map the points, you will get a line that looks like this. The common points that you look at, besides the places where it crosses the x-axis, is at the point of where it is 1 and -1 on the y-axis. And that's going to be at pi over 4. So this point right here is at pi over 4, and also negative pi over 4 for -1. And the pi and the tangent and the cotangent graphs, as said in an earlier section, they repeat every 180 degrees instead of every 360 degrees. So you'll see that this is another situation where we have these pretty points here, here, and here. This is at 0, 0, and therefore this is going to be pi over 2, so this is going to be pi. This is pi comma 0. Now then this right here would be this point here, and it's a little bit off the line, is 3 pi over 4 comma negative 1, and this up here would be 4 fourths, 5 fourths, so this is 5 pi over 4 comma 1. Sorry, that pi looks a little messy there. And this would repeat, and instead of me labeling all the points, I'm just going to do a little call out here. So this was pi over 2, so this next mark here is pi. This is the asymptote x equals 3 pi over 2, which means that this point here is going to be at 7 fourths pi, negative 1. This is going to be at 8 fourths, or 2 pi comma 0. And then this here would be 9 fourths pi comma 1. Then this asymptote line is 10 fourths, or 5 pi over 2, x equals 5 pi over 2. And then this would be 11 fourths pi over negative 1, or 11 fourths pi and negative 1 for the point there, the 1 point here. This would be 12 fourths, or 3 pi comma 0, and this would be 13 fourths pi comma 1 for that point, and this way over here would be 7 pi over 2 asymptote line, so or x equals 7 pi over 2. So this gap right here between the asymptote lines it's always pi units away, but this starts at 3 pi or pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. This gap in these, this is going to be very important for the domain that we're going to talk about in the next page. All right, now we're going to deal with our last equation here, and this is going to be our cotangent. Cotangent of x. Set this up like we have 2, 1, 0, negative 1, negative 2. All right, now for these graphs right here, the asymptote lines are on the pi. So at every unit of pi, so pi, 2 pi, 3 pi, and 4 pi, all these pi's are going to be the asymptote lines. And they're going to cross the x-axis at all the pi over 2 marks. So this is going to be pi over 2 comma 0. This is 2 pi over 2, and this is 3 pi over 2 comma 0, and then this would be 4 pi. This would be 4 pi over 2, which is 2 pi, and so on and so forth. And these swoop down from the top. If you compare them versus the tangent, you can see that that would be the reciprocal of tangent there. So a couple interesting points. Obviously the points you care about are these at 1 and negative 1, and like they were on the tangent, this is going to be at pi over 4 comma 1, and this is going to be at, this is 2 pi over 4, so this would be 3 pi over 4 comma negative 1. So, and then this would be 4 pi over 4, and then this would be 5 pi over 4 on the x to be 1, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi, 11 pi over 4, and I think you're seeing 12 pi over 4. You're seeing that your work with fractions is very important when dealing with these counting by radian measurements, because you're going to have to do this most simplified fraction, because I don't want to see something not reduced. I don't want to see pi as 4 pi over 4. I want to see it as pi, and then you can put the not unreducible fraction 5 pi over 4 comma 1, 6 pi over 4, which is another way of saying 3 pi over 2 comma 0, and then this would be 7 pi over 4 comma negative 1. so on and so forth. Gives you the idea of what is happening here in these pictures, and I hope this gives you a good start. Over the next 3 videos that we're going to make for this worksheet here, we're going to see different ways to shape and transform these over 2 cycles and 5 pretty points for these pictures. All right, well, hey, thank you for watching. I really appreciate it.